your lunch. We have a very special talk from our special invited guest from LifeOmic. We have Erkang Zheng he's the CISO, and Phil Gates and Matt Lavin, who are software architects. And today they're going to be talking about building a virtually air-gapped secure environment in AWS, which is a very interesting topic in terms of how you automate security throughout the development process. And I'll let them dive a lot deeper into that. Thank you very much. Welcome.
Thank you so much, Nick. And thank you, everyone. We're really honored to be here today to give you this presentation. I really want to thank Nick for inviting us because this, to us, is pretty special because all three of us actually graduated from NC State. So it's great to be back at this conference to give a talk here. Like Nick said, I'm the head of security right now at LifeOmic, and prior to that, I was at Fidelity Investment. I was the head of product and software security over there, and IBM security before. So I've been in security throughout my career. And let me tell you a little bit more about LifeOmic. So LifeOmic is a software technology startup that we started a little over a year ago, and it was founded by Dr. Dan Brown. Some of you may know the company Interactive Intelligence, which was a contact center, call center software company that was acquired in 2016 by Genesys. So Dr. Brown founded LifeOmic at the end of 2016. And we're a group of software engineers, security engineers, to build a product on top of AWS. And the product we're building is called the Precision Health Cloud platform in AWS that would allow clinicians and researchers and health IT professionals to store large amount of health data in the cloud and leverage the power of cloud for compute processing, storage, and so on. So as you can imagine, the information is highly sensitive, and so we must have a significant amount of security around it. And as we're building the product, we invested very heavily in security up front. And lately, we've started to branch out a little bit and take our lessons learned and some of the automation and tools that we've built to develop actually a security product that we call JupyterOne around the healthcare industry and not just the LifeOmic Precision Health product itself. So as we go into this journey, there are a number of challenges that we face as a startup. And some of the security challenges, I probably won't repeat that for folks. Everybody here is probably very well aware of the typical security challenges a enterprise and the folks in the industry faces. But for a startup, there are some unique challenges. And these are not just unique to us as for LifeOmic, and these are probably very similar to a lot of the technology startups. And one of them is, how do we allow the development team to move fast, to be able to work anywhere and feel empowered while we ensure security and compliance? And when I say move fast, I'll give you some context. Typically in terms of software development, enterprise development, or enterprise deployment, you may be talking about large releases in a somewhat waterfall-ish model, and even though the development may be agile, the deployment may not be. And in our case, we currently deploy to production on a daily basis up to 20, 30, sometimes more times per day in every single day. And the entire company right now has around 40 people. And when we first started, there were only less than 10 developers and one security person, and that was me. So how do we keep up, right? So the security team, how do we keep up? And how do we let the developers move fast without the security team being a blocker. That is a major challenge for us. We don't have the resource, we don't have the funding to stand up a large security team to be able to support every single developer. And we don't want to. We don't think that's the right approach. And the second challenge is, how do we prove to auditors, and this is probably not new, but in our industry, in the healthcare industry, because we are leveraging cloud, and this may come as common sense to folks in the room, that cloud has evolved so much, it has matured, it's been secure, and if you use it correctly, it can be more secure than traditional environment. But for folks in the traditional healthcare IT industry and the enterprises, the majority of them are still very concerned about using cloud and putting their data in the cloud. So how do we ensure and convince the customers that their data is safe and trust us as a startup who has been around for less than a couple of years? So those are our major challenges that we're trying to solve. So in this little talk that we're going to give, we want to cover these conversations here. So what we built is a security program on top of AWS and for cloud-native operations, for DevOps and security operations, or DevSecOps. And we built a virtually air-gapped, we call it virtually air-gapped because there's no physical air-gap, and this is all software-defined in our production environment in AWS. And when we say virtually air-gapped, we really mean that there's no back-end network connectivity into the environment. We don't allow that. We don't allow access to data internally, other than through a single channel, which is the application itself. And when that's the case, we'll go into a little bit more details on how we build it. We will, naturally the question is, if you have a virtually air-gapped environment, how do you get software in there? And how do you deploy? And how do you deploy really, really fast and still ensure that the process is followed and the security controls are in place? So that's the other topics we're going to cover today as well. And this is not necessarily a standard, this is not a framework, it's our own implementation. It's not a scientific research, so there's not going to be any formulas or fancy math equations there for the professors and doctors in the room. But I do think this will be probably the best talk in this conference. And that's because this is the only talk over lunch. And research shows that people are more engaging and happier and less grumpy when you're having great food. I just made that up. So. All right. So we'll talk about the program a little bit. So keep in mind the challenges that we're trying to solve when we start building the program. And I'll focus on some of the assumptions and the assurances and the culture that we want to have when we develop our security program for LifeOmic. A little bit of a history. And we've been around for a little over a year, and we started our security program journey April last year. That's when I first joined. And we started doing a number of assessments, and based on that, implemented a number of controls. And to date, we've implemented, in terms of both technical controls and process, some of those are still manual processes, there are over 80 of them. And we've achieved HIPAA compliance, and this is sort of the must-have for a healthcare IT company fairly quickly. And going forward, we focus more on, we wanted to take an engineering-first approach, and we want to build automation starting from the very beginning. So as we start to implement these controls, we start to think about how we can automate them, with the help with great people like Phil and Matt on the software engineering team, that we were able to automate a lot of the controls and processes. This one is a bit of a story. And when we were first presenting a version of our approach, we wanted to come up with something interesting for the name of our approach. So this all happened in one day. In the morning, Phil and I were chatting about, what kind of a cool name should we give our security program foundations? And there were 7 principles at the time, and we called it the Magnificent 7. And very quickly, we realized there was something that we missed. And 2 hours later, that turned into the Essential 8. And then by the end of that day, we have a final version of 10 foundational principles for our security program, and that became the LifeOmic Top 10. That just shows you how fast a startup moves. So I'll go over about 4 of those principles when we talk about the architecture of our program. And we began our high trust assessment at the end of last year. And for high trust, this is a compliance and security and compliance framework in the healthcare IT industry. And high trust combines elements from ISO, NIST, PCI, and HIPAA, and created a consolidated framework for healthcare industries. And as of last week, we have officially been certified for our platform. So the first assumption that we are making in building our program is we're using AWS, we're using the cloud. And I think most of us are probably fairly familiar with there's a concept of division of responsibilities in the cloud. AWS itself is inherently secure. So we make the assumption that we can trust it. Or that it will, or AWS or other cloud providers will address any security problems underlying in their infrastructure. So this is the security of the cloud. The hardware, the virtualization, the hypervisor, and the software that governs those compute and storage and database and resources. And AWS provides a number of services, up to 129 of them. And on top of that, we must have security in the cloud, right? These are the things that we have to provide ourselves. And of course, there are security outside of cloud. I'm gonna fast forward a little bit in the interest of time. So the additional assurances and assumptions that we're making as we go into it, one is that we want to make sure that the developers can work anywhere, right? So there's not a single device in our environment that cannot be compromised. That's the assumption that we're making. And we want to make sure that any device that's compromised does not impact anything else in our environment. And we want to be sure that we can track everything. So we will log and we will track everything. So that's how we can protect ourselves. And the other part is automation. And we build automation from the beginning, and we build products that are secure by design and secure by default. And the last part here is we want to engage folks from development, not just security teams. And we're not saying that the security team are the only folks who can do certain things. It's not by the role, it is by collaboration and also transparency over obscurity. And we publish all of our processes and policies online, and we focus on practicality of the solutions and the processes that we build. So let's talk real quick about the air gap. So in our AWS environment, we create the air gaps with these goals. One is that there's no internal network, and the internal folks can only access the applications, the only access to their application logs, and there are no modification to the systems or configurations at any given time unless there's an emergency. And with emergency access, even with privileged access, we want to be able to ensure that there's no access to any customer data. And this is what we promise and what we tell our customers is that their data is always safe because even our internal folks don't have access to them. And in order to achieve that, we implemented a number of gates, right? This is in addition to some of the typical things that we must have, right? Like data encryption and so on and so forth. So all the data is encrypted when it's in the disk and in the database. But on top of that, there are gates to control that. So going to a bit more detail. And these are part of the LifeOmic top 10. And one of them is we take this data-centric zero trust architecture. We segment our environments so that every environment is fully segmented and it has very granular policy to control them. Let me show you a little bit of the architecture. I'll use this to kind of drive the next couple of discussions. So what you see here is how we set up our AWS account. We have a master account that we use for nothing else but to connect the sub-accounts that are operational. And the master account is the one that we integrate with a single sign-on. We use a product called Octet, use the SAML technology to integrate the single sign-on. And when users log on to a master account, they have no access, and they have to switch role when this is a AWS terminology that you can assume a different role into a different sub-accounts. And for each sub-account, and you can see there are multiple layers of a blast area, essentially. The account itself, and there's dev, test, infrastructure, and production environment, they're all separate. And then within the account, there are multiple blast areas within it. And by the nature of virtual private networks, VPCs, and security groups. Oh, you're not seeing it. Okay. This right here. Of course. No VPNs. Yes, and Phil's going to talk about that real quick, right after I kind of finish early on. So the production environment has no VPNs. In the development environment, there's VPNs within that, and then we realized later on that there's not a whole lot of need to actually use the VPNs. And a couple other concepts real quick, and then we'll move on to the actual details of the implementation. And these environments are segmented, and in addition to that, we use serverless technology to ensure that the processes run for the minimal amount of time that they need. So we use AWS Lambda extensively, not just the EC2 instances, because what we want to be able to achieve is to say that when the data is there being accessed, should something happen, you only have a very minimal amount of time, and after that 5 minutes of execution, the process gets killed. And this is how we protect the access into the environments. There are multiple gates, as I mentioned, and you have to pass a single sign-on, you have to pass multi-factor authentication, and once you get into the account, and you have to be able to assume role into the target account in order to gain access into it. And even within that target account, we use a system called Dome9 that provides a level of safety that specifies explicit deny rules for certain risky actions like data access. We use multiple monitoring technologies to monitor the accounts and access. And it's not just one, because we use cloud-based monitoring solutions. We don't want to just trust one provider. We want to be able to make sure that there are multiple ones that are watching each other in case one third-party vendor gets compromised. So back to Dr. Volk's question, how do we get software into this environment? Phil?
Okay, so I'm going to talk about what we call the pipeline. So it's the process of starting from building your code, coding, like writing the code, building it, and then getting it deployed to your actual target environment. So this is a bit of an oversimplification, but there's basically 3 steps I'm going to talk about. There's the coding phase, the build phase, and deploy. And for deploy, I broke it down into multiple environments. The number of environments you have might vary. We actually have dev, test, infra, prod, and a security environment. And so you want to get your code shipped to each of those environments. So starting with code, we have sort of a process that we follow. We get a code review, we make sure the tests pass, and we scan the code for vulnerabilities. We use various tools. We use one called Sneak, which analyzes all of our dependencies to make sure there's no known vulnerabilities in our code. We also use a static code analysis tool called Veracode. We might extend this in the future to add more tools and processes to the coding phase, just as extra checks to make sure before we merge the code to master, we want to make sure it's safe. So once the code gets all these stamps of approval, it gets merged into master, and that kicks off a build in our deployment, our CI/CD system. We use Jenkins, which watches for code changes. When a code's merged to master, it triggers a build. So when the build runs, we actually repeat some of the same steps that we did during the coding phase, which is we run tests again, and we also go ahead and scan the code again for vulnerabilities. Once the build completes, we publish the build artifacts to S3. And I'm going to talk about this a little bit more, but one way that we've kind of deviated a little bit from the industry norm is primarily our build artifacts are Docker images. So when we package up our immutable builds, which I'm not sure if people are familiar with, but immutable builds basically is a binary or package of code that doesn't change as it gets shipped to each environment. So our immutable build is actually a Docker image that represents the deploy process. And a Docker image is something you can actually run and you can parameterize. So when in each environment, you run that Docker image to actually handle the deploy. So once we have our Docker images, we publish them to S3, and we basically have a catalog of all the builds for all the projects that we have in our software product. So I'm going to get to the question about how do we operate without a VPN connection. So as Erkang mentioned, we do have a VPN connection to dev because we give devs to our development environment. So our development environment is a little bit wider open because we kind of provide it as a playground so we can test changes, but there's no customer data there, so we loosen the rules a little bit. However, when we're doing deploys to actual production environments, what we rely on are the public APIs that AWS provides. So these public APIs are, we assume that AWS has done their part in providing secure APIs that are hardened and they're public facing. So all the changes that we trigger are through these public APIs. So one of the things that we do is we don't actually reach into the environment and talk to physical machines or virtual machines to transfer code. We load the code into S3, and then we send basically an API call that says, now trigger this type of job, and that job will go fetch the build artifacts from our secure S3 bucket and then kick off the deploy. We do not rely on any manual changes to our environments. There's no IT person going in and configuring firewalls or security groups or DNS records. All of our changes are orchestrated through code, so everything's fully automated. There's no SSH connections, there's no bastion host, there's no what we alternatively call jump boxes where you hop into a virtual machine that's locked down and then you from there can have access to the environment. We use a product called Terraform, which I'll show in the next slide. What Terraform allows you to do is declaratively describe your infrastructure. So you can describe your DNS records, your security groups, your load balancers, your auto-scaling groups. You describe that in code, so all of your needs as a developer, what you know your application needs, you describe it in the code. And there's a deploy process with Terraform that basically looks at what's currently out there and what you're asking for and automatically applies all the diffs. So if anyone hasn't seen Terraform, this is just a little snippet of how you would define an AWS Route 53 record, which is a DNS entry. There's a name, a type, an alias, but there's different resource types for every infrastructure resource that you might need. There's also support in Terraform for deploying resources to Azure, Google Cloud, and even some on-premise providers. So I'm going to try to describe what a deploy process looks like visually in using our production AWS count as an example. So when we do a build, we have Jenkins that orchestrates the build and deploy process. And we have our production AWS account, which is completely separate from where Jenkins is running. So we have public APIs for launching Lambda functions. Erkang mentioned that we use serverless, but we also use serverless Lambda functions as part of our deploy process. So we expose a very narrow interface that allows Jenkins to invoke Lambda functions via the APIs. So we invoke a Lambda function called launch deploy job, which then launches an ECS task. And ECS is similar to Kubernetes, if you're familiar with it. It basically allows you to run a Docker container in a cluster of compute instances. So the next thing we do is after we kick off the ECS task, we have one more entry point into the environment that allows us to call a Lambda function to poll for the status of that deploy job. So while the deploy job is running, the first thing it does is downloads the build artifact from S3. So instead of pushing the build artifact into the environment, what we do is we send a message to invoke the job. We actually have a signing process where there's a shared secret between Jenkins and the target environment that allows the target environment to verify the signature before actually accepting the deploy job. So the deploy job downloads the build artifact and then launches the deploy container in the ECS cluster. So here it downloads the Docker images, it runs it, and then eventually that job is going to complete. So I'm also going to, one of the things that we need is a way to, we're going to talk about this a little bit later, but we want to make sure that the process is followed. And one of the things that our goals is to automate everything and minimize human intervention as much as possible. There are some cases where you need a human to get involved, and we try to automate those decision points via our whole process. So this is an overview of what our deploy process looks like. And it's actually across two different slides, so the next slide is a continuation of this. But something will trigger a deploy. It's typically through an automatic CI, continuous integration, continuous delivery process. We automatically create a CM ticket, and the CM ticket was important for us because it's a requirement for some of our certifications, security certifications. The CM ticket basically keeps a log of all the activity that triggers a change to production. So we create the CM ticket, and we actually pause the deploy until that CM ticket gets approved. The approval of the CM ticket happens when either our change management bot, which analyzes the changes automatically, determine that it's a safe change, or if it can't be verified to be safe, it goes to a human for approval. But either after it gets auto-approved or human-approved, then the deploy job gets resumed. And the whole piece about the change management bot Matt's going to talk about in the next section of our presentation. So once the deploy job finishes, we stage our deploy files, which basically we copy what's going to be moving into the environment into a temporary location. And we do this to keep track of sort of an audit log of all the changes that got moved into that environment. So this is where we stage the deploy files, which includes the Docker deploy image. We also create a deploy manifest file, which is just a JSON file that's describing the change. And once those files are in place, we launch the deploy job, which is via a Lambda function. The Lambda function, once it gets that invocation, it verifies the signature. So if the signature is valid, then it moves on to the next step of launching the deploy worker in our ECS cluster, which is again is like Kubernetes. If the deploy signature is not valid, we go to this abort state. We just kill the job and we don't allow it to run. The signature might be invalid if, say, a hacker got into your environment and figured out that they can invoke this Lambda function, but they don't know the shared secret, so that's another little extra layer of protection. So as in parallel, we also are polling for the job status. Because there's no network connection, we can't get a real-time update of the status, so we have a very narrow interface where we call a Lambda function just to poll for the job status. I can't remember the interval, but it's something like every 5 seconds we poll for the status. So that while the deploy worker is running, it launches our deploy Docker image, and at some point it's going to complete. And while the deploy image is running, it's doing things such as running any custom bash scripts, or most typically it's running Terraform, which is automatically applying the changes that are necessary to get the infrastructure to the right state. All right, so the next section of our talk is about the change management bot.
So I am first and foremost a developer and impatient one at that. And so this came out of trying to speed up my process. And so I think most of this will be pretty straightforward, but some assumption here is that a change management process is needed for compliance. And the heart of the change management process is just what is changing in production? Is it documented? Is it understood that the processes that are required according to our change management process, have they been followed? And just a paper trail of that. And so what happens in the old method is that you would, let's say I have some changes I'd like to promote to production, and it's been 3 days since the last change I promoted to production. And so I'm filling out a ticket that's telling Erkang, hey, come on, this is good code. Here's all the changes I made. And so I need to then craft a list of changes that have happened in the last 3 days. But, you know, I've been pulled in a million different directions. I've had interrupts all day long. I can't remember what I did. So I just come up with a kind of a lame text response that says, I changed something over here and something over here, and I'm pretty sure that's all I did. And then, yeah, it leads to the question of, well, how much detail do you really need, right? And so what happens is it's not good, right? I mean, developers come up with basically as little as Erkang will accept. And it's the truth, right? I mean, that's just life. And so I had a thought while I was crafting one of these things, which is to say, we could do significantly better in terms of detail, and could be significantly faster if we just automated a lot of this, because it's not something that I need to figure out myself. And the worst case of this is that I craft this, you know, carefully created list of changes, and then I submit it, and I've done everything right. I've gotten all my code reviews. I've done security scans, and I just wait. I needed this change to go out to production to get a bug fix, but I don't know, Erkang is driving home, or his kid's interrupting him at home. And there's just no need, because, you know, I followed the processes. Why am I sitting around waiting for this? And it's not much better on Erkang's side either. I don't mean to say it's all his fault, but I gave him a list of changes that I just made up. I mean, if I was him, I wouldn't trust me at all, right? But it's not easy for him to calculate all the stuff I've done in the last 3 days either. And so he would, in the old way, have to go through and track down all the work I did and then re-verify that I followed all the processes. And I've given him a list of stuff, but really, if he's a good security guy, it's useless, because I just typed it up. There's nothing there. It's just what I said. So he's not even going to be able to look at what I did, really, and if he wants to be thorough. So, yeah, so let's automate it. That's the easy answer, right? So instead, now what I provide is a summary text for Erkang. And this is really something like a high-level description of why I'm interested in promoting something to production. And this is significantly less important from a paper trail standpoint because I'm not trying to justify all the changes I've done. I'm just saying, here's an interesting reason why this production should happen, this production promotion should happen. And what I do need to provide is the Jenkins build that's going to be promoted. Now, this is the linchpin here because this build, when Erkang approves, is exactly the same build that's going to get deployed. And so we know, because the deployment automation is going to pull this exact build number, when I say I'm deploying this thing, Erkang now knows exactly what I'm deploying. And with that exact Jenkins reference, I can then, through automation, go and calculate all the changes that have happened since the last production push. And this means that I don't have to think about what I did. Erkang doesn't have to try to trust me or not trust me about are the lists correct. And the automation can go one step further than that. It can start going through not just what I was supposed to do, but what Erkang was supposed to do as well, which is for each of those changes that were made, did somebody other than me review it? Did they approve the change to go out? And was there a security scan run for that build that I'm trying to promote? And occasionally you run into situations where maybe a change was not approved by another human. Maybe I cheated the process, or maybe I just made a mistake and I accidentally merged before one of my peers had reviewed it. The bot will detect that as well. It'll tell Erkang, hey, I'm not rejecting this, but you need to check it out because there's something odd going on here. Right, so this is going to go a little bit more into detail on how exactly this is implemented. And I am assuming a little bit of familiarity here with things like Jenkins and Bitbucket, but Bitbucket is just a Git repository. And the key to this success is that all of these systems, Jira, Jenkins, and Bitbucket, they have APIs that developers can access. And so first thing that happens is I create a CM ticket, and it included that Jenkins build number. So CM bot, this is a change management approval bot. It gets notified through a Jira webhook, and it says, hey, somebody's requested a change. Why don't you check out what he's requested? Then it goes out to Jenkins. Well, I guess it kind of does this in parallel. It goes to Jira, and it says, well, what's the last build that was promoted for this project? Because a project has a huge history of changes, but I don't really need to look at everything that was done. I just need to look at everything that was done since the last deploy. Because presumably the last deploy was approved. That's why it's out there. And so now we're just looking at what's new. So I get the last approval. I go out to Jenkins and I say, hey, what's changed since that last approval? And it comes back with a list of Git commits. And then with those Git commits, I can look at Bitbucket. And Bitbucket has this nice feature that it'll actually let me fetch all the approvals and code review comments for a particular merge. And so I can take a list of Git commits. I can look through Bitbucket, make sure that all the commits were reviewed and approved by somebody other than myself. And assuming that's good, it moves along, I can look at the Jenkins logs to see if a security scan was run. And so if the security scan was run, then I can also get links to the results for that scan. And finally, I collect all this data, and again, this is just a point in time snapshot. I think Phil mentioned it earlier. This is just what we're doing today, but there's no reason why more steps couldn't be added as we change our security rules or our CM approval rules. But I take all the data I've got, and I make a judgment about whether it should be approved or not. And I craft, and you'll see in a next slide, you'll see what this looks like, but I make a little comment that describes what I did, I being the security bot, what the security bot reviewed and found to be true, and then makes a judgment. And if it's approved, then it'll go ahead and it'll mark the CM ticket, the change management ticket as approved, and the build will continue to deploy. And if not, it'll leave Erkang the message that says, here's why I did not approve it. And I'll go ahead. So here is, you good? Oh, faster. Yeah. Okay, well, I only have 2 quick slides. So here's an example of one that was approved. It's quite simple. It just says, summary, I'm going to approve this. And here's why. Only two things changed. They were both approved by other peers, and there was a security scan found. And here's an example of one that was not approved. And the reason it wasn't is because some of the changes that went in were not reviewed by peers. And it's interesting here. I'll go to the next slide because this to me was the most exciting part about this, is that if you have two possible futures for your changes, one is that you follow all the steps and you get an automated approval, and production builds and production promotions can happen within minutes. People get really excited about that. And if you find that, well, most of the time your changes go out to production in minutes, but if somebody circumvents the process because they think they're trying to, oh, I don't really need a peer review on this change, and all of a sudden it punts out to a human to do the reviews, and your deploy takes hours instead of minutes, all of a sudden you have people mad that they didn't get peer reviews, or they didn't follow the security processes. And so it really flips the interest of the developer to do what was right instead of what was fast in the short term. So, I mean, this to me has been the best part about it, is that you find developers sort of opting into optimal security practices, because when they follow the security practices as we've laid out, then they can get really fast, unblocked promotions to production. And I hope to push on this more, to do more automation to help, drive more cultural change. And Erkang is going to do a quick summary of some of the things we've learned in other areas.
Just to summarize real quick, and this is just part of our process, right? This is not the whole security program. It's a couple of steps in our implementation. And the key thing here, there are two key things here. One is the whole process, if it were followed by design, there's no human intervention at all, from pushing code into code being deployed into production. And all of the steps in between are captured. And second important thing is that when the deploy happens, everything happens within that environment itself. There's no outside influence. The only thing that comes from the outside is, well, deploy this code, and this code is signed. And everything else happens within the environment without any additional connectivities into the environment itself. There are some lessons learned and future development that we want to do to keep improving the process and the tools that we build. Any questions from the audience?